Hey guys, we're going to talk about some independent practice now. So this is for 6-2, and this is stuff that you should be working on Wednesday. So it begins on page 381. So this is independent practice, page 381. Number one, so we have to on 1, 2, and 3 find each function value. So they say find f of 7 if f of x equals 5x. Well, in this case, f of 7, we substitute that in where we see an x, so f of 7 is equal to 35. Grade number 2, they want f of 9 if f of x is equal to x plus 13. So that just becomes 9 plus 13, or 22. So f of 9 is equal to 22. Great. For number 3, guys, they want f of 4 if f of x equals 3x minus 1. We substitute the 4 in, so we get 3 times 4, PEMDAS, right order of operations. So 3 times 4 is 12. 12 minus 1 is 11. So f of 4, when f of x is 3x minus 1, is equal to 11. Right, next we have choose 4 values of x to make a function table for each function, then state the domain and range of the function. All right, so we have 4, 5, and 6. So 4, 5, 6. All right, so we have x, f of x, and I give you your rule. Right, 6x minus 4. So I said to go ahead and choose 4 values. You can do -2, -1, 0, 1. Or you can do, let's see, what do we have? 5 minus 2x. So we have x, f of x. I'm going to do -1, 0, 1, and 2 here. And then for 6, we have 7 plus 3x, along with x, and along with f of x, I'll do -2, -1, 0, and 1. Just, once again, please don't be ridiculous and don't do something wacky like -6,000, 329. Don't do anything like that. So -2 comes in here for x. 6 times -1, 6 times 0, and 6 times 1. All right, so -12 minus 4, -16. -6 plus -4 is -10. Anything times 0 is 0. So 0 minus 4 is -4. And then 6 minus 4 is 2. All right, over here on number 5, so we have 5 minus 2 times -1. 5 minus 2 times 0. 5 minus 2 times 1. 5 minus 2 times 2. So negative and negative is positive. So 5 plus 2 yields 7. 5 minus 0 is anything times 0, 0 is 5. 5 minus 2 is 3. And 5 minus 4 is 1. We come over here, 7 plus 3 times -2. 7 plus 3 times -1. 7 plus 3 times 0. 7 plus 3 times 1. All right, so what does that yield? So opposite signs, multiply, divided, negative. 7 minus 6 is 1. 7 minus 3 is 4. 7 plus 0 is 7, because anything times 0 is 0. And 3 times 1 is 3. 7 plus 3 is 10. All right, I hope you all got that. You were successful with that. We'll take a look now at number 7. In the recent 82 game season, Dwight Howard of the Orlando Magic averaged 20.7 points per game. His approximate total points scored, P of G, is a function of the number of games that he played. Ooh. So his approximate total points scored is equal to his per game average times the number of games that he played, right? Because it's a function of the number of games he played. A, identify the independent and dependent variables. Independent variable here, number of games played. Nothing else depends on that, that is what it is, right? Dependent variable is going to be his total points. So that's P. And the reason why is because once we define the number of games that he's participated in, we multiply that number by 20.7 and we get a definition for P of G. We receive an output value for the function at that particular value of X. So what values, domain, and range makes sense? Once again, nothing negative. We can start at 0 and we can get more positive. So for domain and range here, makes sense to say that our values are greater than or equal to 0. We come here to C, write a function to represent the total points scored, which I did as I was trying to understand the problem. Now they want us to figure out how many points he scored in 9 games. So that's 20.7 times 9. Come here to the calculator, clear this out. 20.7 times 9, 186.3. So 186.3 points in 9 games. Now, since it's approximately 20.7 points per game, that is approximate total points scored. So 186.3, however you wanted to round it, if you wanted to say, oh, well, 0.3 means it should be down to 186, or if you're going to say, well, since he has 0.3 points, that's not nothing, I'm going to round up to 187. That's fine. That's fine. All right, if you said 186 or 187, depending on your interpretation, that's fine. I just go ahead and stick with the 186.3 right now. That's sufficient. Let's take a look at the next page. Model with mathematics, write a function. See what we can do right here. Write a function to represent the total cost, C, of printing and shipping any number of pictures, P. All right, I can only spend 25 bucks. How many pictures can I print? So they say go back to graphic novel at the start of the chapter. And I think actually if you look at what I gave you, what I did was I eliminated this so you don't have to worry about that. Especially because people are having issues with the volume 2 because we got out of school and then we shut down so you have a chance to go back and get it. Don't worry about that. It's not an important problem. You haven't missed anything. All right? What is becoming important, things like 9 and 10, because they're saying, okay, you guys feel pretty comfortable with integers. Now we're going to shake things up and give you a fraction. All right? So what happens if f of x is 2x plus 1/3, but I want f of 5/6? All right? So that's 2 times 5 over 6 plus 1/3. Well, guys, that's 2 over 1, right? So think about this now. So we have in our numerator, we have a 2. In this denominator, we have a 6. So 2 goes into 2 once, 2 goes into 6 3 times. So we have 5/3 plus 1/3, which gives us 6/3 or 2. All right? Similar idea on 10. We have f of 5/8. So just as you get comfortable with integers, they decide to shake things up by giving us fractions. All right, so they want to know what happens here if f of x is equal to 4x minus 1/4. We'll substitute your 5/8 in, right? Do that for x. So 4 times 5/8. 4 goes into 4 once, goes into 8 twice. So we have 5 halves minus 1/4. So 5 halves is really, right, if we multiply 2 by 2, we have to do 5 times 2. Because what this is, guys, it's a weird version of 1, right? 2 halves. So 2 times 5 is 10. 2 times 2 is 4. So we have 10/4 minus 1/4, which I'm just writing as everything over 4. So 10/4 minus 1/4, 10 minus 1 is 9. And both things share the denominator of 4. So f of 5/8 is 9/4. All right, then we have the HOT, the higher order thinking problems. For 11, I want you to reason abstractly. They say, if f of -3 is equal to -8, write a function rule and find the function values for 0 and negative and a positive value for x. So this right here is really high, be creative time. That's what this means. So they tell us f of -3 equals -8, and they say, go crazy, figure out what this could be for yourself. All right, so let's say, what if I want to do something with 2? What if I wanted to say 2x? So 2 times -3 is -6. -6 plus something equals -8. That something is -2, right? Because I can add 6 to both sides, so blank equals -2. So now I've created a rule, and yours doesn't. It doesn't have to look like this. Please understand that it doesn't have to look like this. It could be anything else, right? Could be x minus 5. Could be any of an infinite number of possible equations. Just be as creative as you need to be right there. So they say do it for a -0 and a positive value. So 2 times -2 is -4. 2 times 0 is 0. 2 times 2 is 4. So my output, when my input value is -2, my output is -6. If I input a 0, my output is -2. And if I input a 2, my output is a 2. All right, so I hope you guys see that. And what do they have for us on 12? That's a higher order thinking problem as well. Ooh, they want us now. So 11's good because it exercises your imagination, because in 12 we have tables and they want us to write a function rule for each function, right? So we get an x, we get an f of x. All right, so for a, we have -3, -30, -1, -10, 220, and 660. Huh. Well, it certainly looks like if I do -3 times 10 is -30. -1 times 10 is -10. 2 times 10 is 20. 6 times 10 is 60. So it looks like a good rule for this one on 12a would be that f of x equals 10x. We come to 12b, we get -5, -9, -1, -5, 3, -1, 7, 3. So the difference between each of these values is 4, right? Because we did +4, +4, +4. From -9 to -5, we added 4, added 4, added 4. So something about an x plus 4, okay, because that's our common difference. right there. So I'm wondering, if we had -4, would that be -8, -3, -7, -2, and -6? Because if I have a +4 here and a +4 here, kind of looks like as I'm increasing by 1 here, I'm increasing by 1 here, right? So if we operate with that, let's just play that out and see what happens. So I'd have 0, -4, I'd have 1, -3, 2, -2, 3, -1, 4, 0, 5, 1, 6, 2. Ooh, very interesting right here. So we start out, even though we're increasing by 4 each time, because we have 0, -4. So -4 is our B value, right? So what we actually want right here is not an x plus 4. We want an x minus 4, guys. X minus 4. And we'll take a look at 12C. So we have -2, -3, 1, 3, 3, 7, 5, 11. So we're going up by 3 here, increases 6. Going up by 2 from 1 to 3. Going up by 4. From 3 to 5, we're going up 2. And from 7 to 11, we're going up 4. So it looks like if I'm going up 4 for every 2 that I'm increasing on my x, it looks like every time I go up 1 on my x, it looks like my y's are going to be increasing by 2. Huh. So if that's the case, and then if we have -2, -3, if I increased x by 1, I would increase y by 2. If I increased x by 1 again, I'd increase y by 2, which would take me from 0 to 1, increase x by 1, increase 1 by 2. Hey, I have that point. Seems like that's a good idea, right? That'd be 2, 5, 3, 7, x plus 1, y plus 2, x plus 1, y plus 2. Look at that. It seems like I've hit on something that fits every single one of the points we're given. So we have 1 for our b, right, because we're looking at y equals mx plus b. And how are we increasing each time? Well, if we go up 1x, we're increasing by 2 on the y-axis. So why don't we say that that looks like a slope of 2 right there, 2x plus 1. 2 times 5 is 10, 10 plus 1 is 11. So our f of x is 2x plus 1. We're at 2x plus 1. Let's see, right here, do we need anything else like that with this? Because we're just increasing by 1 each time. Yeah, -5 minus 4. Yep, no, that's good, guys. So we don't need to do anything else with this one. This one's good on 12B. I just want to make sure I didn't have to go back and readjust anything. So 7 minus 4 is 3. 3 minus 4 is -1. -1 minus 4 is -5. So we don't have to do anything else there. What about 12B? Oof. -2, -5. 1, 1, 3, 5, 5, 9. So 3 to 5 is a plus 2. Going up plus 4. 1 to 3 is a plus 2. Plus 4. Kind of looks like as x increases by 1, y is increasing by 2 again. Right there. Which is interesting because if y is increasing by 2, seems reasonable to conclude that we're going to have a slope of 2. So I wonder what our value be is 0. Right? So if we increased x by 1, we have to increase y by 2. If we increased x by 1, we have to increase y by 2. Now, does that fit here? If we increase x by 1, increase y by 2, yeah. X by 1, y by 2. So that takes us to 3, 5. Increase x by 1, y by 2. Increase that value by 1. And that y value by 2, we get this. So our rule is f of x equals 2x minus 1. The last thing we're going to take a look at right here is 13, test practice. Melinda's buying CDs that cost $12.99 each. So $12.99 per CD. There's a shipping charge, so it's a flat rate. So $4.95 for shipping and handling. Which function represents the total costs, C of M, of M CDs? Well, it's $12.99 per CD. We have to have that. All right, and then we have that flat rate. So $12.99 M plus $4.95. So what answer options are we given? So we have C of M equals, so A, B, C, D. So C of M, so these little quotation marks in there so you know that that means C of M. I'm repeating the C of M down here on the left-hand side. So for A, they tell us M, we have $12.99 plus $4.95, which is out because they don't tell us that the shipping, that the $4.95 is for every CD. So that's out. For B, we have $4.95M plus $12.99, which is wrong because it's $12.99 per CD is not $4.95 per CD. So they put the M next to the incorrect number right there. We take a look at C, we get $12.99M plus $4.95. Hey, that's what we're looking for. So our winning answer is C. Why is D wrong? Because here, they give us $12.99 minus $4.95, which makes absolutely no sense at all. It's absolutely ridiculous. You're talking about shipping. They're not going to deduct that from the price of every CD. So D is just a nonsensical answer. So your answer right there is C.